Welcome to Science and Sleep. Here, here we slow down together, listening to the breaths of the universe and the gentle stories of science. Whether you are curled up in a blanket, lying still on the sofa, or simply seeking a quiet moment before come to right place, let each tale carry you slowly through the stars, through time, and through mysteries never yet touched. If you find this piece worthwhile, don't forget to like, subscribe, and stay with me until the end of the journey. It is you who help this little light continue to shine within the galaxy of dreaming souls. In the vast canvas of the universe, few things are as mysterious and captivating as black holes. They are like dark pauses within the galactic symphony, where the familiar laws of physics suddenly become strange. But to understand why they exist, we must turn back time, returning to the life and death of stars. A star, such as our sun, is not simply a shining ball of fire. It is a colossal engine where hydrogen nuclei fuse into helium, releasing immense energy. The light you saw from the sun this morning actually began its journey over 8 minutes ago, and that is proof of the power of nuclear fusion. For billions of years, the fragile balance between the inward pull of gravity and the outward push of energy pressure has kept the star steadily burning. However, like every story, fuel eventually runs out. When the hydrogen in the core gradually disappears, this balance begins to falter. For small or medium-sized stars, the journey ends rather peacefully. They swell into red giants, then gently shed their outer layers, leaving behind a faint remnant, a white dwarf. But for massive stars, at least 20 times the mass of the sun, the end is far from gentle. When nuclear reactions can no longer resist gravity, the core collapses almost instantly, and the entire immense mass plunges inward. In that moment, one of the most violent events in the universe occurs, a supernova. The star's outer layers are hurled into space with tremendous energy, shining brighter than a galaxy for a brief time. But the core, if heavy enough, does not stop there. It continues to contract, surpassing the limits of protons, neutrons, and all forms of ordinary matter. And then a black hole is born. Yet black holes are unlike any other objects. Calling them holes sounds accurate, but in truth, they are neither voids nor punctures. They are regions of space where gravity has become absolute. The boundary surrounding them is called the event horizon, a point of no return. Once this boundary is crossed, even light, the fastest thing in the universe, cannot escape. Strangely enough, black holes, when viewed from the outside, appear remarkably simple. They have no surface features, no cracks or glow, only a dark sphere. The only hints of their existence come from how they affect the world around them. Bending light, causing nearby stars to orbit in unusual paths, and sometimes tearing matter into brilliant streams before swallowing it into eternal darkness. If the universe were a vast stage, black holes would be the characters hidden in the shadows, present only through their influence, not their form. They are like secrets, chapters concealed in the cosmic book, forcing us to infer their presence from faint traces left behind. A natural question arises: what truly lies inside a black hole? At its center, theory suggests the existence of a singularity, where density becomes infinite and the current laws of physics no longer apply. Einstein's general relativity describes black holes perfectly on the outside, but as we approach the singularity, the equations break down. Meanwhile, quantum mechanics, which explains the microscopic world, is not yet strong enough to unify with gravity. Thus, the singularity is not only a scientific challenge, but also a philosophical question. Are there limits humanity will never overcome? What makes black holes even more fascinating is their diversity. There are small ones, only a few times the mass of the sun, called stellar mass black holes. But there are also giants, millions or even billions of times the sun's mass, supermassive black holes sitting at the centers of galaxies, including our own Milky Way. Between these extremes, scientists are searching for evidence of intermediate mass black holes, the middle children that may explain many puzzles of cosmic structure formation. Yet, regardless of size, one thing is always true. Black holes are not greedy monsters sucking everything in. They only affect what comes too close. From a distance, they behave like any other massive object in the universe. If the sun were suddenly to turn into a black hole without exploding, Earth would still orbit it as it does now, only in a world that had become cold and dark. This shows that black holes are not symbols of blind destruction, but testaments to nature's extremes. They are the endpoints of stellar evolution, redefining space and time at their limits. And in their perfect silence, they echo a message. The universe is not only a place for life, but also a stage for realities beyond human intuition. In the next part, we will not only see black holes as the destinations of dying stars, but also as silent musicians tuning entire galaxies. From bending light into gravitational lenses to emitting gravitational waves when colliding, black holes do not merely exist in quiet isolation. They whisper to us about the missing pieces of the cosmic puzzle. And thanks to new tools like the Event Horizon Telescope or gravitational wave observatories, we have begun to listen to that story. If in the previous part black holes appeared as hidden figures in the dark, then when they meet, the universe suddenly turns into an explosive stage. Imagine two black holes, each tens of times heavier than the sun, orbiting each other in a fateful dance. Each spin makes them gradually lose energy, their orbit shrinking tighter and tighter. The speed increases, the rhythm quickens, and then in the final moment, they plunge into each other, merging into a new black hole. The extraordinary thing is that this collision is not only an event of space, but also an event of time. As two black holes orbit and merge, they shake the very fabric of space-time, creating ripples that spread across the universe, gravitational waves. Einstein predicted this in 1916 as a natural consequence of general relativity. But for decades, it remained a beautiful prediction on paper, for who could imagine a way to measure such tiny vibrations in space? It took a century for humans to discover how to listen to that silent music. In 2015, the LIGO, Laser Interferometer Gravitational Wave Observatory, detected the first signal, gravitational waves from two black holes colliding more than a billion light years from Earth. That signal was not loud, not dazzling like the light of a supernova, but just a faint ripple, lasting less than a second. Yet it was enough to confirm the universe is whispering to us in an entirely new language. Pause for a moment and imagine. The event that took place billions of years ago, when Earth did not even have multicellular life, left a trace, and that trace traveled across the vast cosmos to reach us at the very moment humanity was just mature enough to recognize it. One could say that was not only a scientific achievement, but also a sacred moment. Since that day, we have detected dozens, then hundreds of other gravitational wave signals. Each signal is a story, black holes colliding, neutron stars merging, the universe trembling. It is like opening a sixth sense, allowing us to perceive the universe not only through light, but through its very rhythm of vibration. If traditional telescopes are the eyes that see the sky, then gravitational wave detectors are the ears that listen to the universe's breath. Yet, each discovery sparks more questions. Why are there pairs of black holes that are unusually massive? How did they form, and could there be even more colossal collisions, releasing gravitational waves strong enough to shake entire galaxies? The universe once again reveals secrets while concealing a deeper layer. But the story of black holes does not stop at numbers or equations. It reaches down to the very root of philosophy. What is reality? As you approach the event horizon, time for you slows down. If you could see someone falling into a black hole, you would see them slow down, freezing at the edge as if suspended forever. But for that person, time flows normally, and they would pass the boundary without even noticing. Two different realities coexist, simply because space-time has been bent to its limit. This leads to a great paradox. Does information truly disappear when it falls into a black hole? According to quantum mechanics, information can never be completely destroyed. But if it passes beyond the event horizon, does it still exist? This is the black hole information paradox, one of the hottest problems in modern physics. Stephen Hawking once suggested that black holes might leak information through quantum radiation, what we now call Hawking radiation. This idea shook physics as it opened up the possibility that black holes are not eternal, but could evaporate over time, eventually vanishing completely. If that is true, then black holes are not endless pits, but temporary chapters in the universe's life cycle. They are born from the death of stars, devour matter, then gradually fade, returning energy to space. That death, if it exists, opens the door to a new cycle. All of this makes black holes one of the most powerful symbols of the limits of human knowledge. They are where relativity and quantum mechanics, the two great pillars of physics, come into conflict. And at the very point of conflict may lie the solution to the theory of everything, which scientists have sought for decades. But beyond equations, black holes also remind us of humility. In a universe so vast it defies imagination, where there are regions of darkness that swallow light itself, our existence is but a tiny flame. Yet that flame shines just enough to recognize the darkness, to ask questions, and to listen to echoes from collisions billions of light years away. And perhaps that is the most beautiful meaning. Black holes do not just teach us about physics, but also about ourselves. That knowledge is not a destination, but a journey. That every mystery solved only opens another mystery, and that even in absolute darkness, humanity still finds a way to shine with curiosity. In this silent universe, black holes are not just the final destinations of stars. They are also storytellers, recording history through their very invisible presence. Each black hole is a vast archive, preserving the memory of a star that once burned brightly, once shone, and once left its mark upon space-time. When a massive star collapses, it does not vanish entirely. Gravity holds its remains tightly, compressing them so much that not a single particle of light can escape. And in that very moment, a black hole is born, both an ending and a new beginning in the story of the cosmos. Imagine you are standing at the edge of an event horizon. There are no signs, no clear boundaries telling you that you are about to cross a threshold of no return. It appears to be just an ordinary region of space, yet each step draws you deeper into an irreversible destiny. If you throw an object into it, you would see it slow down, its light redden and fade, as if time itself were slowing before your eyes. But for that object, no change is felt. It continues to fall, to move, until it crosses the boundary and vanishes forever from sight. There, not only is space bent, but time itself becomes an inescapable stream. When you look at a black hole, you are not actually seeing it. What you see is light bent from all directions, from stars, from gas clouds, from blazing plasma spirals being drawn in. Matter, as it approaches a black hole, is stretched, compressed, and heated by friction until it glows brilliantly. The accretion disk, the colossal whirlpool surrounding a black hole, is one of the brightest structures in the universe. It is a beautiful paradox. From a dark object, we witness a dazzling halo. And if you listen, you will realize that black holes have their own voice, not a voice of sound, but of gravitational waves. These subtle ripples in space-time itself are the way black holes whisper to the universe. They testify that space is not static, but can tremble like the surface of a lake. Each time two black holes collide, the cosmos quakes, sending waves that can travel billions of light years to reach our ears. And when humans built machines sensitive enough to hear them, we listened, for the first time in history, to the silent music of the universe. What makes black holes fascinating is not only their extreme physical phenomena, but also their philosophical meaning. They remind us that there are natural limits knowledge cannot easily overcome. The event horizon is like a secret veil, revealing that there are domains of understanding humanity cannot yet directly access. But at the same time, black holes prove the power of intellect. Even without touching them, we can infer, calculate, observe indirectly, and weave together a picture of their nature. Black holes also pose a profound question about the nature of reality. What happens to information when it falls in? The laws of physics say information can never be destroyed. Yet when a book, a star, or even a speck of dust crosses the event horizon, all seems to vanish. This is the information paradox, one of the greatest mysteries that has fueled debate among physicists for decades. Some hypotheses suggest the information still exists, encoded on the surface of the event horizon as a three-dimensional image of reality, like a vast hologram. If so, our universe itself may be but a projection of a deeper reality we cannot yet imagine. Meanwhile, in distant galaxies, supermassive black holes, millions or even billions of times the mass of the Sun, govern the dynamics of entire galaxies. They reign at the center, swallowing gas and dust, unleashing streams of energy so powerful they can shape the birth of new stars. Again, a paradox emerges. Objects thought to devour everything may serve as the beating hearts that regulate a galaxy's rhythm. Perhaps it is precisely this duality that makes black holes a symbol of the universe. They are both endings and beginnings. both destruction and creation, both invisible and radiant. They are proof that the cosmos does not operate by simple opposites, but through the harmony of paradoxes. And as we sit here in the stillness of Earth, hearing about black holes billions of light years away, we realize that there is an invisible connection between us and them. Gravity, the force that keeps our feet on the ground, is the same force that binds galaxies together and drives the spiraling dances of black holes, different in scale yet governed by the same laws. An apple falling to the ground or a star being swallowed by a black hole are but different versions of the same cosmic melody. In this silence, black holes remind us that science is not just numbers or equations. It is also an emotional journey, an effort to listen to what is almost impossible to hear, to see beauty in the unseen, to feel the connection between our small selves and the vast universe. And perhaps it is precisely this silence that makes them our strangest companions, voiceless, invisible, yet powerful enough to whisper the deepest secrets of reality. When two black holes finally merge, the universe does not erupt in fireworks of light, but instead in a deep, silent, majestic breath. It is the moment when spacetime itself becomes an instrument, resonating with gravitational waves spreading across the cosmos. Those ripples, though lasting only fractions of a second, carry within them an ancient story, a story of billions of years drifting, twisting, colliding, and ultimately merging. These final vibrations are like echoes from a distant symphony. They fade as they reach Earth, but thanks to sophisticated gravitational wave telescopes, humanity has been able to hear the song of the universe. Not with ears, but with instruments so precise they can detect changes smaller than the diameter of a proton. When that signal was first recorded in 2015, the entire scientific world seemed to hold its breath. It was not only a triumph of technology, but also a confirmation that the universe can whisper, and we have learned how to listen. What is special about these signals is that they do not only speak of the present, but also unlock the past. From a fleeting ripple, physicists can reconstruct the mass, the spin, even the distance between two black holes. They can envision the journey of giant stars billions of years ago when they exploded into supernovae only to collapse into dark cores. And as those cores slowly spiraled toward each other, they composed an invisible epic that humanity has only just learned to hear. The merger of black holes, therefore, is not merely a physical phenomenon. It is a cosmic journal, where each word is etched in gravity. Every merger is a door opening, allowing us to peer into the very fabric of spacetime. There are even hypotheses suggesting that if we observe carefully enough, we might catch glimpses of new physics beyond Einstein's general relativity. That is one reason scientists today are eager to hunt gravitational waves, for they may reveal truths that light has never told us. Imagine this: for billions of years, two black holes spiral into each other unseen. But only when they merge, in a heartbeat's instant, can that signal travel across billions of light years to reach us, tiny yet clear. Isn't that one of the most beautiful examples of the universe's patience? Going further, understanding these mergers also helps us decipher how galaxies evolve. For when black holes merge, they do not only transform themselves, but also affect their surroundings. The immense energy released can stir gas and dust, suppressing or igniting the birth of new stars. In a sense, black holes, symbols of destruction, are also conductors, orchestrating the rhythm of galactic creation. This opens up a fascinating paradox. These invisible entities, which seem to devour everything, are the very foundations that keep the universe creating. They are both destroyers and creators, and perhaps that is the true nature of the cosmos, a cycle between dissolution and genesis, between endings and beginnings. As we marvel at these stories, it is worth remembering that we ourselves live in a galaxy with a supermassive black hole at its center, Sagittarius A star. It lies about 26,000 light years from Earth. You may think that distance too great to matter, but imagine, every star you see in the night sky, every spiral of the galaxy, is influenced in some way by its silent gravity. Even this tiny planet we call home is caught in the spiral dance around that invisible center. There is something quiet yet weighty. When we look at distant black hole mergers, we are also glimpsing the future of our own Milky Way. For one day, our galaxy will collide with Andromeda, And in about 4 billion years, the supermassive black holes at their centers will begin to draw closer, opening one of the grandest dances ever to be. That thought may make you feel small, yet also comforted. For even as you sit here, in the brief flicker of a human life, you are part of a much larger story, a story the universe continues to write, line by line, in the language of gravity and time. And so, when you listen to the gravitational waves echoing from afar, perhaps you are also hearing a more familiar melody, the heartbeat of the universe itself, a slow, steady beat, yet one that never stops. When we talk about astronomy, we often think of light, the shimmering pictures that telescopes have painted over centuries. But the story of LIGO opens a new chapter. It doesn't just observe the universe with eyes, but also with ears. For the first time, humanity not only sees the universe, but also listens to it. This changes the way we perceive our very existence in the vastness of space. Imagine a violin placed in a room of absolute silence. People look at it, admiring the beauty of the wood, the slender shape. But the violin remains silent, and no one knows what its sound is like. Then one day, an artist lifts the violin to their shoulder, draws the bow, and a melody emerges. The universe before 2015 was just like that violin, beautiful, radiant, but silent. And LIGO is the first bow to touch the cosmic strings, letting us hear the music hidden for billions of years. The structure of LIGO at first glance seems simple, just two straight tunnels, each 4 kilometers long, set at right angles to each other, with mirrors and a laser inside. But behind this simplicity lies a technological masterpiece. These laser beams are incredibly sensitive, so much so that even a vibration smaller than 1,000th the size of an atomic nucleus can be recorded. Humanity has built a machine to hear the tiny ripples in space-time itself, an idea even Einstein once doubted. And then the first signal arrived. On September 14th, 2015, a short chirp appeared in the data, barely 0.2 seconds long, yet it contained a story spanning over a billion years. It was two black holes, each dozens of times more massive than the sun, spiraling inward and crashing together. In that moment of collision, they released more energy than all the light from every star in the universe combined, but without shining. Instead, that energy turned into gravitational waves, quietly traveling across the cosmos until they reached Earth. That moment can be seen as humanity gaining a new sense. We had always been familiar with light, from visible light to radio waves, X-rays, gamma rays, all variations of the same phenomenon. But gravitational waves are different. They are not blocked by cosmic dust, not hindered by matter, not disturbed by interference. They carry original information straight from their source, like a letter that has never been opened during its journey of billions of years. From that first discovery, a door has opened. A series of black hole collisions have been recorded, each event a song with its own rhythm. Some resound powerfully and intensely, others are deeper and more drawn out. These echoes show us that the universe is not as silent as we thought, but is constantly breathing, singing, and changing. What makes LIGO special is not only the detection of gravitational waves, but also the way it allows us to ask new questions. For instance, why do some black holes have masses far greater than predicted? Why are their binary systems spinning at seemingly impossible speeds? Each signal is not only an answer, but also a question sent back to us. Try to imagine, the universe is like an endless ocean. Before, we only observed the surface, the sparkling lights of stars, the radiant beams of galaxies. But with LIGO, for the first time, we sense the undercurrents beneath the surface, and those waves reveal that this ocean is far more dynamic than we ever thought. Gravitational waves even promise to let us look further back into the past than any telescope of light can. Light is blocked by the dense fog of the early universe, only a few 100,000 years after the Big Bang. But gravitational waves can pass through that fog. One day, if technology becomes sensitive enough, we might hear the echoes from the dawn of the cosmos, the first drumbeats of time itself. This carries not only scientific meaning, but also profound philosophical significance. It reminds us that the universe is not silent, but always whispering to us, and that human existence, tiny creatures on an ordinary planet, is intelligent enough to create delicate tools capable of listening to the very breath of the universe. Behind all the complex mathematics and engineering, there remains a simple beauty: two black holes spiraling around each other, then merging into one. A cycle ends, a new entity is born. In that fleeting moment, the universe resounds with a melody, and thanks to LIGO, we hear it. Perhaps this is the intersection of science and art, of reason and emotion, of the cosmos and humanity. When you lie down and think about this, remember, even in the deepest darkness, there are still heartbeats echoing, gentle, steady, unceasing. And once we learn how to listen, we will realize we have never truly been alone in the universe. When we think about the merger of supermassive black holes, it is hard not to be overwhelmed by the scale of what is happening. Each black hole is the center of a galaxy, an invisible guardian, silently governing the motion of billions of stars. Yet, over time, gravity guides these giants closer together, and when they finally meet, the space-time around them seems to tremble. It is not just a collision, but a symphony orchestrated by the universe itself. What is fascinating is that this merging process rarely unfolds quietly. Before two supermassive black holes reach their final stage, their galaxies undergo a period of violent chaos. Vast streams of gas are compressed and ignite into waves of new star formation. Old stars are thrown off their familiar orbits, streaking away like tiny sparks in the night sea. Some stars are even flung completely out of their galaxies, wandering forever in the cold void between galaxies. But at the center, invisible to ordinary light, two colossal black holes begin a spiraling dance. At first, they move slowly as if probing one another. Then, over time, the orbit tightens, the speed increases, and the energy released is not light, but ripples of gravitational waves spreading across the universe. These waves have extremely low frequencies, so slow that the human ear cannot hear them, but future instruments like LISA will transform them into the background music of the cosmos. Imagine this. In the final moment before two supermassive black holes merge, the energy released in gravitational waves exceeds the combined light of all the stars. And yet, not a single ray escapes from the heart of the event. Everything happens in darkness, revealed only through vibrations in the fabric of space-time. The universe, at some level, is whispering to us in the language of gravity itself. What captivates scientists is not only the scale, but also the secrets gravitational waves can reveal. From the shape of the signal, they can calculate the mass of the new black hole, its spin rate, and even the kick force that might hurl it out of its galaxy. There are scenarios so extreme that the merged black hole is ejected like a cosmic bullet, hurtling into the infinite void with no galaxy to hold it back. If so, there would exist wandering black holes, belonging to no galaxy, forever alone in the dark. The more astronomers observe, the more they realize black hole mergers are not isolated but levers that reshape entire galaxies. They affect star formation rates, the distribution of matter, and even the morphology of galaxies for billions of years to come. One could say that each time two supermassive black holes merge, the universe rewrites a new chapter in its evolutionary book. Yet, we must also admit that this is only the beginning of our journey of understanding. All the data collected by LIGO, Virgo, and in the future by LISA are just like the opening notes of an endless symphony. Each signal is a hint, a clue showing how intricate and wondrous the universe truly is. Think about this. We stand on a tiny planet, orbiting an ordinary star at the edge of a spiral galaxy. And yet from here, we can sense the echoes of events that took place billions of light years away. The gravitational waves detected by instruments are not just data, but the imprints of cataclysmic cosmic moments. They remind us that, although small, humanity has the ability to listen to and understand the heartbeat of the cosmos. In the future, as technology advances, we may be able to record a fuller cosmic symphony, not only hearing the short, sharp thuds of stellar mass black holes, but also the long, deep hums of supermassive ones. At that point, gravitational wave astronomy will become a sixth sense, complementing the eyes that optical telescopes have given us. Through it, the deepest dark regions where light cannot reach will gradually emerge into human knowledge. And perhaps the most beautiful thing here is not just science, but the idea that we, finite beings, can connect with the infinite. Each signal, no matter how faint, is a quiet conversation between humanity and the universe. The universe speaks through waves, and for the first time, we have learned how to listen. Perhaps no phenomenon in the universe is as awe-inspiring and humbling as the moment two black holes merge. No telescope can directly capture that image. There are no flames, no cosmic dust exploding in brilliance, no glowing remnants like when a star ends its life. Instead, this event unfolds in absolute silence, like a performance hidden behind the curtain of space-time. And it is precisely this silence that makes it more majestic. For what is happening is not merely the collision of matter, but a fundamental transformation in the very structure of the universe. In their spiraling, the two black holes seem to be taking part in an ancient dance, a choreography dictated by gravity itself. Their rhythm is not measured in human minutes, but in the breaths of galaxies, in millions of years compressed. Each whirl is a whisper of space-time, a note in a symphony that human ears cannot hear, but which delicate gravitational wave detectors can record. From these almost invisible tremors, we know that the universe is still staging colossal dramas beyond imagination. What is astonishing is that, to a distant observer, the moment of merging seems never to arrive. Time near the event horizon stretches so much that each instant appears frozen. The two black holes, instead of colliding in a dramatic instant, seem to hover, suspended in the abyss of time. This is not an optical illusion, but a real effect, precisely predicted by general relativity. It shows that time, which we usually think of as a uniform flow, is actually only a local experience. For what happens near the black hole, the event unfolds quickly. But for us, at a safe distance, that dance becomes a motionless sculpture. This image poses a poetic paradox. An event can be both finished and never finished, depending on where you stand in the universe. It is like a mirror reflecting two different stories. The story of matter inside, where the merger happens and creates a new black hole, and the story of those outside, where everything is frozen in an endless embrace. This is not just a mathematical outcome. It is a profound message that time is not. Every person, every star, every photon lives in its own rhythm. And from that difference, a new beauty is born. If you could stand at the edge of a black hole, you would see the universe outside rushing by faster. Millions of years could pass in just a few moments from your perspective. Conversely, those far away would see you slow down as if trapped in a still frame. The universe, in this way, becomes a film never synchronized, where each actor lives in their own timeline, intersecting only for brief moments. When the two black holes finally become one, the silence is absolute. No sound escapes, because sound needs matter to travel. The only thing that escapes this scene is gravitational waves, ripples in the very fabric of space-time. They are like the echoes of a cosmic bell spreading across galaxies. Billions of years later, those ripples can still reach Earth, passing through our bodies without us feeling them. Yet instruments like LIGO or Virgo can hear them with precision so great they detect changes smaller than 1,000th the size of a proton. This is a testament to the miraculous capacity of humanity. We cannot see, we cannot touch, but we can still listen to the universe with patience and intellect. The merged black hole leaves no memory of its chaotic past. It retains only mass, spin, and electric charge, if any. Everything else, the original orbits, the violent oscillations, the fierce gravitational waves, vanishes beyond the event horizon. Physicists call this the no-hair theorem. Black holes have no traces or peculiar features beyond those basic parameters. This absolute reduction is both astonishing and unsettling. It raises the question, can the memory of the universe be erased so easily? Or is all the information still there, encoded in the waves that have radiated away in a holographic picture of space-time? This question remains unanswered. But perhaps it is precisely this mystery that is its greatest value. Each time we detect a merger, we are not only measuring mass or velocity, we are testing the foundations of physics, asking whether Einstein still holds under the most extreme conditions. And so far, every test has confirmed the universe still follows the rhythm he predicted. Yet science never stops. Perhaps one day, in a fading echo from a distant black hole, we will hear a discordant note, a strange melody, hinting at a new truth beyond all current understanding. In the boundless darkness, where light itself cannot escape, those mergers are anything but silent. They are vast symphonies, written in the very warping of space-time. And each time we hear a melody from them, we do not merely witness a cosmic event, but confront the limits of human intellect, and at the same time realize that those limits can always expand. As supercomputers weave those simulations, we do not only see dry numbers, but an entire symphony of space-time. Every ray of light, every spiraling orbit, every trembling rhythm in those graphics is the whisper of Einstein's equations, the language that describes how the universe bends itself. These simulations give us what the naked eye can never have, the chance to witness how light turns into waves, how time becomes an image, how one of the greatest secrets of the universe is carved into a visual shape. But those images are not just the art of mathematics. They are also a window opening onto a deep philosophy, the boundary between what we can know and what will forever lie beyond reach. A black hole can be described precisely with a few numbers, mass, spin, charge, but inside it is an entire universe impossible to know. That is the great paradox. Simplicity on the outside concealing infinite complexity within. Imagine this. You are sitting before a screen, watching two virtual black holes orbit each other. They dance in a waltz with no audience but the universe itself. The light from the gas and dust around them is bent, twisted into strange halos like distorted cosmic mirrors. And then, in a fleeting instant, they crash into each other. All light vanishes. Only the silence of darkness remains. Yet within that silence, enormous energy is released as gravitational waves, rippling through space like waves across an infinite lake. We, small beings on Earth, can listen to that invisible music. The giant gravitational wave detectors like LIGO and Virgo operate with such precision that they can detect a change smaller than 1,000th of a proton's diameter. When the signal arrives, it is not an explosion, not a flash of light, but only a subtle ring, lasting less than a second. Yet from that fleeting echo, we can reconstruct an entire collision between objects tens of times heavier than the sun. It is like hearing a single musical note, and yet knowing the whole orchestra, the entire concert hall, the entire story of the musicians. And here, the concert hall is the universe. The musician is gravity, and the symphony is the story that has traveled billions of light years to reach us. From a fragile echo, we learn that the universe is not silent. It stirs, it trembles, it resonates. Those ripples are the way the universe recounts its history. We have heard two black holes merge. Then we heard two neutron stars collide, creating brilliant light and gold and silver in the cosmos. We learned something more, that the universe is not only to be observed, but also to be listened to. But the greatest question still remains. What happens to the information inside a black hole? Does everything that falls in disappear forever, or is it encoded onto the boundary of the event horizon like a giant holographic screen? This is not only a problem of physics, but a problem of perception. If information can be lost, then do the fundamental laws of the universe, conservation, still hold? If information is preserved, how can it escape when no light can? These debates have lasted for decades, from Hawking to the young physicists of today. Each hypothesis opens a new worldview, black holes as gateways, as data vaults, or even as embryos of other universes. And it is precisely here that black holes become the meeting place of science and philosophy, of experiment and imagination. When you close your eyes and think of a black hole, you may picture a rounded darkness among countless stars. But in truth, it is not an object. It is a boundary, a region of space where every path leads inward. It has no surface, no color, no smell. It is absolute emptiness, yet at the same time, the embodiment of infinite density, nothingness containing everything. Perhaps that is why black holes captivate our imaginations so. They are both an ending and a beginning. They are the dead ends of time, yet also the possible gateways of new universes. They are reminders that what we know is only a fragile shell covering a profound reality. And at some level, the journey of contemplating black holes is like the journey of contemplating ourselves. We too are surrounded by the unknowable. We too carry secrets, dark regions even we have not touched. And sometimes it is in the silence, in the stillness, that we recognize the value of continuing to ask questions, even knowing that we may never find the answers. The universe does not rush to respond. It resonates through gravitational waves, through stretched light, through mysteries suspended in space. And when we listen, we become part of that symphony. In the primordial era of the universe, everything was still chaotic. The Big Bang had scattered energy and matter everywhere, but it took hundreds of millions of years before order began to emerge from that chaos. As the scorching plasma gradually cooled, protons and electrons combined, creating hydrogen and helium, the first elements. In that primordial fog, tiny ripples of matter density, almost invisible, became the seeds of everything we see today: stars, galaxies, and even giant black holes. It was in places where light and darkness had yet to be clearly defined that primordial black holes may have formed. Some hypotheses suggest that right after the universe began, regions of extremely high density collapsed directly, forming tiny black holes with masses ranging from just a few tons to thousands of suns. These are called primordial black holes, and although they have never been observed directly, the idea of their existence remains one of the most fascinating mysteries in cosmology. If they truly exist, they may have acted as gravitational nuclei, pulling in more gas and dust, serving as the launch pads for the formation of the first galactic structures. Then the universe entered the era of the first stars, the population 3 generation. These were massive luminous stars, yet short lived. They lasted only a few million years before collapsing in violent supernova explosions, scattering the first heavy elements into space. Some of these stars ended their lives by leaving behind a collapsed core, forming stellar mass black holes. These black holes, little by little, contributed to the grander cosmic picture, merging, accreting more matter, and gradually evolving into the supermassive black holes we see today at the centers of galaxies. What makes this story even more wondrous is its swiftness. Only a few 100 million years after the Big Bang, a fleeting moment on the cosmic scale, there is already evidence of supermassive black holes with masses of billions of suns. How could they grow so fast? This remains a question that puzzles scientists. One possibility is that they began as enormous seeds, not ordinary stellar black holes, but the direct collapse of gigantic gas clouds. These seeds could have masses of tens of thousands of suns right from the start, allowing them to grow rapidly by devouring surrounding matter. Meanwhile, galaxies were being born. Dark matter, a mysterious non-luminous component, created the invisible gravitational scaffolding for galaxies. Baryonic gas, the familiar kind of matter that makes up stars and planets, fell into these dark matter halos, cooled down, and began clumping into rotating disks. And at the center of each budding structure, black holes played the role of a conductor. They didn't simply consume matter, but also fed back. When they swallowed too much, they unleashed enormous energy in the form of radiation and jets, regulating the star formation rate of entire galaxies. One of the strongest pieces of evidence for the central role of black holes comes from observing quasars, intensely active galactic nuclei, brighter than the galaxies that host them. They are proof of the existence of supermassive black holes in the young universe. Quasars are not only lighthouses illuminating the primordial era, but also reminders that black holes and galaxies have been intertwined since the very first chapters of cosmic history. At this point, a picture gradually emerges. Black holes are not byproducts of galaxies, but companions. Galaxies feed black holes with streams of gas and stars, while black holes give back energy, shaping the evolutionary pace of the entire galaxy. This symbiosis may be the reason why our universe has such a rich and stable structure. There are even bolder hypotheses. Not only galaxies, but the very early universe itself may have been shaped by the presence of black holes. Some physicists speculate that black holes could be gateways to other universes, or that our own universe might have been born from a collapse in a higher dimensional space. Though direct evidence is lacking, such ideas show that black holes are not just physical phenomena, but also endless sources of human imagination. Looking back at that journey, from tiny fluctuations in primordial plasma to the birth of stars, their collapse into black holes, and finally the emergence of vast spiral galaxies, we realize that darkness is never just an end. On the contrary, it is precisely from that darkness that the universe found ways to organize itself, to evolve, to create. Black holes, once thought of only as light-devouring monsters, turn out to be silent storytellers, preserving the memory of beginnings while also opening doors to future possibilities. When we think of black holes, we often imagine them as devouring machines in the dark, greedily pulling everything nearby. But the truth is far more magnificent. A black hole is not only an endpoint, it is also the beginning of large-scale transformations in the universe. Each time a black hole swallows matter, it does not simply erase information, but simultaneously releases energy into its surroundings. brilliant X-rays from accretion disks, jets of plasma shooting out tens of thousands of light years. All these phenomena signal that, right within the absolute darkness, there exists a source of unimaginable light and power. Scientists believe that it was precisely these columns of energy that helped illuminate the early universe. When the first stars ended their life cycles, young black holes were formed. They pulled in surrounding matter and released powerful streams of radiation, pushing away gas and dust, clearing regions of space enough for light to spread. Without that process, perhaps the universe would still be shrouded in the opaque mist of primordial hydrogen. The very first particles of light that we can see from the early universe may have shone thanks to the indirect assistance of the earliest black holes. What makes black holes so extraordinary is the way they connect the extremely large with the extremely small. On the macroscopic scale, they shape galaxies. On the microscopic scale, they force us to confront the limits of physics. Einstein's general relativity, which describes the curvature of spacetime, works brilliantly on the scale of galaxies, planets, and even black hole mergers. But as we approach the singularity where density and spacetime curvature become infinite, the equations fail. Here, quantum mechanics, the realm of fundamental particles, must be taken into account. And it is precisely at this intersection, where relativity and quantum theory meet, that black holes become the golden key to a unified theory. One of the most controversial yet fascinating ideas is the black hole information paradox. If everything falling into a black hole disappears, is information permanently destroyed? This contradicts quantum mechanics, where information is never lost. Stephen Hawking once asserted that information would vanish, but later he changed his stance, suggesting that information could be encoded in the radiation emitted by black holes. This debate is not merely philosophical. It is a thought experiment helping physicists shape new hypotheses about quantum gravity. In a sense, black holes are both a question mark and a doorway. Imagine this. At the center of a vast spiral galaxy, a supermassive black hole spins, governing the movement of billions of stars. Those stars then form planets, and planets give rise to life. This means that in some way, our very existence today is also influenced by the invisible hand of ancient black holes. They are not merely symbols of destruction, but also architects of foundations, sustaining the rhythm of the cosmos. Today, thanks to gravitational wave observatories like LIGO and Virgo, we do not only see black holes through bent light, but we can also hear them through the vibrations of space-time itself, a fleeting signal lasting only a few milliseconds, yet carrying within it the story of billions of years. The recent black hole mergers we have recorded prove that those spiral dances truly happen frequently and are still unfolding throughout the universe. From a human perspective, this is astonishing. We, tiny creatures on a blue planet, can now sense the tremors of events billions of light years away. Each gravitational wave signal reaching us is like an ancient postcard sent from the young universe and only just arriving. And by decoding them, we are gradually rewriting the diary of cosmic history, a diary that black holes themselves helped preserve. But the story does not end there. Some bold hypotheses suggest that black holes could be gateways to other universes. Perhaps within them lies not just collapse, but also the seed of a new universe, separate and parallel to the one we inhabit. Though still a distant idea, it shows that black holes are not only a subject of science, but also ignite the imagination about the very nature of existence. And when we view black holes from that perspective, we realize they are not merely distant, mysterious entities. They are also mirrors reflecting humanity's deepest questions about beginnings, endings, and the meaning of time. In the darkness of black holes, we see the brilliance of knowledge. In the silence of gravity, we hear the echoes of the universe. And in every endless spiral, we see the shadow of ourselves, small yet eager to learn, fragile yet persistent in our steps, driven by the belief that the closer we move toward the mystery, the more clearly we will understand life itself. In the world of gravity, dramas do not always have a perfect ending. We often imagine black holes as giant beings, calm and certain, but when three black holes get entangled, stability turns into chaos. A triple system is not a warm embrace, but an endless tug of war. Each mass is a whisper of gravity, and the three whispers overlap, transforming into a chaotic melody. Over time, asymmetry arises, and one black hole often becomes the outcast. It is hurled off the cosmic stage like wandering aimlessly through the cold expanse, becoming a lonely nomad without a galaxy. Those wandering black holes may be out there, invisible to any telescope. With no bright accretion disk, no surrounding matter to consume, they leave almost no trace. Yet their weight is real, silently warping space as they pass through. And if one day one of these wanderers drifts across the neighborhood of a galaxy, it could sow the seeds of new turmoil, a rebirth dance of gravity. Not every merger is graceful. Sometimes the collision of black holes produces not only pure gravitational waves, but also leaves behind a colossal kick. When two black holes merge, the energy radiated as gravitational waves is not always evenly distributed. A portion escapes more strongly in one direction, like a sudden jerk backward. The newborn black hole can be flung out of its own galaxy, crossing millions of light years, dragging along the bent fabric of space. This is one of the quietest tragedies of the cosmos, a massive black hole, the product of billions of years of evolution, becoming an exile. What astonishes us is that even within chaos, there is an elusive beauty. Picture three black holes entwined in an unstable waltz, one ultimately expelled, the remaining two spiraling into each other, emitting invisible ripples that run across the universe. On Earth, billions of years later, a tiny detector may quiver to that signal. Amidst the cosmic noise, humankind may hear a distant heartbeat, the trace of a tragedy that unfolded long before life had even sprouted here. It is the marvelous intersection of science and poetry. We do not only calculate, we also feel the grandeur through technology forged by our own hands. The truth is, the universe does not operate like a flawless machine. It resembles more an improvisational piece of music than a pre-written symphony. Black holes, despite their image of stillness, are in fact improvisational artists in this grand performance. Sometimes they merge into a solemn whole, sometimes they push one another away, sometimes they vanish with sudden leaps out of galaxies. This uncertainty does not diminish the beauty. It is precisely what makes the universe lively and captivating. There is something intriguing. These upheavals, in the long run, are the way the universe writes new order. A black hole cast out does not mean an end, but the beginning of another journey. An unbalanced merger can lead to restructuring, paving the way for galaxies to transform. Even loss carries creativity, as if the universe never accepts absolute stillness, but always seeks rebirth from its own unrest. If we follow to the very end of the future, when stars have faded, when the last faint light has vanished, perhaps the wandering black holes will be the universe's final storytellers. They will carry with them the memory of countless mergers, countless kicks, countless chaotic dances. They need no light to shine. Their mere existence is enough to keep the cosmos on a slow heartbeat, stretched across unimaginable eras. And who knows, in the gravitational ripples they leave behind, distant civilizations of the future, or in some other universe, may be able to read this story. A story that needs no words, no light, only the trembling of space-time. It is the oldest and most enduring language, the language of gravity itself. Looking back, we may see that even in the chaos of black holes, there is a message being delivered. Patience. The universe does not hurry. It lets spiraling dances last for billions of years. It allows the kicks, the expulsions, the solitary journeys to unfold in boundless silence. And it is precisely this patience, not fleeting outbursts, that shapes the destiny of all things. Perhaps what makes black holes such powerful symbols is not only their destructive might, but also their ability to tell stories through silence. Every merger, every expulsion, every tremor of space-time is a small chapter in the universe's wordless book. And we, who happen to exist in the rare pause between two cosmic beats, have the chance to listen, to record, and to dream. Thus, when we speak of the chaos of black holes, we are not only speaking of physics, we are speaking of a mirror reflecting how the universe works, messy but full of meaning, harsh yet hiding beauty. And perhaps if we listen carefully, we will realize that even that chaos carries its own melody, the melody of gravity, the melody of eternity. When that fragile signal finally echoed to Earth, it was not a sound that human ears could hear. It was like a delicate touch, a tiny ripple in the very fabric of reality. Scientists call it a gravitational wave, but in truth, it was the distant whisper of two black holes melting into one, after billions of years of waiting. The detectors on Earth, gigantic constructions built with ultra-pure mirrors and lasers, had remained silent for years, only to await that exact moment. When the curve of data on the screen leapt upward, the world knew. We had just heard the heartbeat of the universe. Not everyone realized how important this was. For centuries, humanity had only been able to observe the universe through light, through what the eyes could see, from radio waves to gamma rays. But light has its limits. It can be obscured by dust, scattered, or simply not emitted in dark events like the merging of black holes. Gravitational waves are different. They are not blocked, not stopped. They carry the story intact from their origin, crossing every galaxy, traversing billions of light years without weakening. For the first time, we could listen to the universe in a completely new way, not only seeing but also sensing its profound rhythm. In that moment, the entire scientific community seemed to hold its breath. The world did not just hear about two black holes colliding, but also witnessed vivid evidence of the theory Einstein had predicted more than a century earlier. Equations once regarded as pure intellect had now transformed into measurable data. What once seemed like an abstract problem of space-time had now become a doorway to reality. As if the universe whispered, "You were right, and I still have countless stories to tell." Imagine this: two black holes, each dozens of times more massive than the sun, whirling around one another at nearly the speed of light. With each orbit, they sent out delicate ripples in space-time, like distant drums echoing across a field. As they plunged into each other, their immense mass transformed, part of it into pure energy, bursting out as gravitational waves. In just a few short seconds, that energy exceeded the light from the entire universe combined. Yet, by the time it reached us, the signal was weaker than the width of a proton. It was this delicacy that made measurement not just science, but a wonder of human intellect. But this was more than a scientific discovery. It raised a question. If we can hear gravitational waves, how many other melodies of the universe are still waiting? Perhaps out there, thousands or even millions of other pairs of black holes are whirling, sending out their silent heartbeats. Perhaps there are collisions of neutron stars, rare events even more violent, where for a fleeting moment gold and platinum are forged and cast into space. Each signal, each ripple is a different story, a new chapter in the endless epic of the universe. What moves me most is this: all of this happened long before humans existed. When the two black holes began their fateful spiral dance, Earth had not yet formed. When those gravitational waves were born, even the dinosaurs may not yet have appeared. And only now, when the signal touched the detectors crafted by human hands, could we listen. There is something humbling in realizing we are merely latecomers, tuning in to ancient echoes of the cosmos. Yet within that smallness lies a strange beauty. Because through intellect, curiosity, and the desire to understand, humans dared to build colossal machines just to hear vibrations smaller than an atomic nucleus. And through that boldness, we touched a new layer of reality. We are not only observing the universe with our eyes, but also learning to listen with the heart of science. When you think about this, you see the universe is not only a dark, distant space, but also a stage where immense tragedies and grand dances unfold, silent yet majestic. Every signal we detect is a reminder that we, though small, can still connect with things vast beyond imagination. Gravitational waves are not just data. They are the heartbeat of the cosmos, the tale of stars long dead, the proof that in darkness there are songs without words that echo forever. And perhaps as you lie still in the night, listening to these words, let your imagination drift with those ripples. Picture that right now, somewhere in the universe, another pair of black holes is slowly drawing closer. Billions of years from now, the signal of their dance will reach some other distant civilization. Perhaps they too will lie quietly in the dark, listening, and feel the same wonder, the same stirring emotion as we do today. In the vastness of space, the universe seems like a gigantic book of which we have only just turned the first few pages. Black holes, often imagined as dark abysses swallowing everything, are in fact important characters in that story. They are not absolute endings, but more like punctuation marks, where one chapter closes, making way for another to open. Black holes are memories, the silent heartbeat of space, where life, light, and even destruction blend into an eternal melody. The most wondrous thing is to hear these melodies, we do not need eyes. No one can ever see a black hole since light cannot escape them, but we can sense their presence through gravitational waves, delicate ripples traveling across space-time. That is how the universe whispers to us, like an invisible symphony spreading through the fabric of reality. And only in the past few decades has humanity become skillful enough to build colossal instruments capable of hearing that symphony. Observatories like LIGO or Virgo, with lasers so precise they can detect a change smaller than the diameter of a proton, have opened a new sense for us. Now, beyond the astronomical eyes that look at the sky, we have cosmic ears to hear the distant echoes. And astonishingly, when those ears rang for the first time, it was not with a grand orchestra, but with a short chirp. A simple sound, less than a second long, yet enough to prove the universe has its own language, and we have only just begun to understand it. Within that chirp lay a story billions of years long. Two massive stars exploded into supernovae, leaving behind two black holes, then quietly orbited each other in an endless dance before merging into one. At that moment, the universe trembled, and that tremor spread everywhere, reaching us today. If you pause to think, you will find it strange. Those vibrations set off long before Earth even existed. When they began their journey, the sun had not yet been born, and our planet was nothing but cosmic dust. And yet now, after billions of years, that signal gently touches human technology, a tiny creature that has existed for only a few million years. That moment is like a handshake across time, between the primordial universe and us, the ever-curious beings who never stop asking questions. This makes us realize a simple yet profound truth. We are not outside the universe, but a part of it. The atoms that make up your body, the carbon in your cells, the iron in your blood, the calcium in your bones, were all forged in stars that died billions of years ago. They once exploded, once shone brightly, and from that ash, new matter was born. In a way, you are the memory of stars. And when you listen to the ripples from two merging black holes, you are in truth listening to your distant relatives in the cosmic family having a conversation. Perhaps that is why those signals bring such a strangely soothing feeling. Not loud, not dazzling, not explosive, but just a gentle resonance, enough to remind us everything has its own rhythm. The universe is not only chaos, it is also patience. It is slow, long-lasting, yet always moving, always changing. In the silences, there is always a deep current, and when we attune to it, we find a rare comfort. It is easy to think of black holes as symbols of endings, but try to see them from another angle. The merging of two black holes is not a full stop, but a rebirth. A new black hole, larger, stronger, and a signal spreading across the universe. Isn't it the same in our lives? Closures, farewells, things we thought were endings, sometimes open the way to new beginnings. The universe, in its own way, teaches us about the cycle of everything. And if tonight you are listening, pay attention. In the silence around you, there are also vibrations. Your heartbeat, your breath, tiny but steady ripples. They too are a kind of gravitational wave, marking that you are alive, that you exist, that you are part of this grand story. And when you close your eyes, perhaps you will realize that sleep is no different from a journey, a gentle union between consciousness and unconsciousness, between day and night, between questions and dreams. Black holes, in the end, are not monsters that devour. They are milestones, anchors on the cosmic map, reminding us that everything changes, that light and shadow, birth and death are but mirrored sides of one single existence. And in their silent spirals, we learn the greatest lesson. Sometimes the strongest things come from stillness.